Loud. Great. Okay, so we are going to do kind of an Octant overview. Let me share. I have a document here that we're gonna use. We'll switch between this and my IDE, but so can you all see the document? Great.
Yes.
So Milan had already has GitHub set up, has ZenHub set up. Submitted a PR today to kind of update the contributing documentation around this, but put a little more detail in there about how we do things and such. So I'll do a quick overview of our workflow. We try to best effort within reason, prefer async over synchronous. So updating issues and tickets and creating documents and making sure we're recording videos and sharing those out when we do synchronous communication. This way that people across all the time zones and different interest areas and people who are new to the project, or maybe they were in the project then left and then came back, they can all get caught up on information and get those details as they need. So we're just putting effort into making sure that we're not having a lot of kind of one-off out-of-band conversations in Slack and then never updating any of the issues or documents around it, because it can be a nightmare to go through Slack and kind of find stuff. So our workflow is really simple right now. The issue represents work to be done or work that's currently being done. PRs represent things that close or fix issues, and then we review it and merge it. We use ZenHub, and we do a best effort to keep that kind of up to date with what we're working on. We do, I would say overall, we do a poor job of that, but it's something that we're putting effort into and just trying to get better at. So I think as the team grows, it'll become easier to keep it up to date, because we right now it's just, it's just Sam and I, and then we have a conversation and we know exactly what we're working on. So the motivation to go update move the card from one column to another in ZenHub is generally fairly low, but we've been working on trying to make sure that we have good habits there. So nothing unusual there in our workflow.
Yeah, makes sense.
So I covered that really fast. Because you mentioned you had already kind of looked at everything. So were there any specific questions you had about our tools or workflow?
No, I think,
okay.
Just hopping on GitHub, downloading everything and running it locally was pretty easy.
Okay, great.
So it's a good sign.
Yeah. So then I'll move on. I want to, so I made this list and I kind of want to get your feedback on it. If this seems like a good thing to cover, then this is what I'll walk through and cover. But if there's something in here that you are really interested in or missing, or feel like you don't need, just let me know now and I'll update this and we can do it.
No, this looks great. Maybe just if you can start with the big picture.
Yep.
And then, diving components and
okay.
data models and everything else.
Yeah, that sounds good. So Octant itself is intended to be kind of gives you a high fidelity view of your namespace, and that gives you kind of information about how your namespace is the health of it and how it's structured and the way things interact with each other. And it does this through using the Kubernetes API to display objects and information in a way that helps show relationships and kind of give you the data that you need up front. I don't, for whatever reason, I don't know why, I don't have an instance of Octant running right now. I probably should. So I know why I don't, because I was switching between branches. So the goal of Octant is really to help kind of developers and people who are building things for Kubernetes kind of get visual, my dog, to kind of get that visual feedback of what they're doing and how those services and interactions are happening. It also has the ability to kind of provide you with details around how things aren't working. So we expose things like the logs for pods and the status of individual objects and things like that, where you will be able to see through our resource viewer that how things are all interconnected and if there's currently any errors or warning conditions around those objects. So
Cool.
that's kind of like the high level take on Octant. I don't know if Sam has anything to add there. Cool. All right. Do you have questions?
So you basically have, looking through code, seems like you have a server-side code that's in Go, and then client is JavaScript and Angular, right?
Yeah, so I can touch on that a little bit here as we move into kind of like the ideas around Octant. So Octant is kind of broken up into these two pieces. So for right now, I don't think about code, just think about these two separate pieces. We have this stream of data that's coming out from Octant, and then we have these components. And so the stream of data is essentially a JSON, like it's JSON marshaled data, and components are what take that JSON data and turn it into what we see and interact with in the UI. So on the front end, it's really just watching a data stream and then taking that data stream and transforming it into components. And the back end is taking, watching a data stream, in this case, it's the Kubernetes API, and it's taking that and it's converting it into those components. And so, and then the go-between is just that it's marshaling it out to JSON, and we then convert that into the visual representation. The back end that is watching the Kubernetes stream and then converting it into our own stream of components, that's done with Go. And the front end that is consuming the stream and rendering it out into the HTML version of the components is Angular.
Cool.
The front end itself, to the best of our ability, doesn't actually know what these things are or how they interact with one another, or that they're even, it has no sense of their concrete type or their form. We just create a set of generic components, and then we assemble those components in a way that the front end code, the Angular code, displays them how we want. So all of the views that you see when you're looking at the front end are defined and laid out on the back end. They're placed onto the stream with printers, and then the front end will consume and display that.
And how does the front end connect to back end? Is it?
It's a WebSocket, yeah.
Okay, cool.
Yep.
Sweet. Sounds pretty simple architecture.
Yeah, and so I can move into more of kind of the how there, which is the structure, as I just said, is Go on the back end, Angular on the front end. We also have a piece on the front end that is moving towards an Electron app, which is currently under the Denali module. That'll be that application-centric view where you'll have that more native look and feel, and Octant will be just an application that runs on all the platforms. Backend wise, what we do is we have Go, and we use gRPC as the mechanism for communicating between the server and the client. And then we use a library called GoRice, which takes all of our front end assets and packages them together with the back end assets so that we can run the back end service as well as serve. Currently, we run the back end service and we serve up the front end files all within one single binary.
I see.
And the way that's done is through the GoRice module does that. It packages everything together so that we can have that single entry point binary. I don't know exactly what that will all look like as we move towards Electron, because I know Electron has some mechanisms for packaging and tooling. But for now, that's just, those are the Electron part of things is a completely separate module on the front end. And so we're not dealing with changing how the executable is currently built at the moment.
Okay.
Before I move on, any questions there?
Yeah. I'm not so familiar with the GoRice, but I'll take a look into that.
You know, honestly, I'm not super familiar with it either. I just know that we use it, like I know the purpose we use it for, and it works, and it's just kind of there and doing its thing. So, yeah, I don't actually know the details of how it works. I just know that it does work. But we can we can circle back to the details on GoRice later if that's something you're interested in. So as for, I touched on this. I'm going through this stuff really fast because I don't want to take up too much of our time. But if you want me to slow down or you want me to cover a thing more in depth, just please call it out.
Oh, this is great so far. Thank you.
Okay. So this will probably be the last section that I'll get into before we start to actually like look at some of the code. So, and this is around just how Octant gets information. We have two methods that we use to get information. We use an informer, which is, if you're not familiar with informers, it's a part of the Kubernetes API and allows you to sit and watch a set of resources or a namespace for updates to different objects. And so we use informers in combination with a dynamic client. So when we don't have access, when the informer does not have information, so the cache that backs the informer does not have information that we want yet, we will then use the dynamic client to directly connect to the API and fetch that information out while we wait for the informers to warm the cache.
I see.
So that's one place where Octant gets its information from, is basically direct from the Kubernetes API. And the second place Octant gets information from is from plugins. And it gets its information from plugins using a service interface that we've created that allows plugins to subscribe to associate event handlers for the various object types within Kubernetes or custom resources. So to Octant, once things are being called on the like loaded and printed into the stream, there's no difference between information being fed from a plugin versus information being fed from the Kubernetes API. Okay. There is some differences as we kind of merge and coalesce the set of information, but once it's on the stream itself, there's really no differentiation between plugin information and Kubernetes information.
So when you said the service, is that Kubernetes service that you guys deploy or on Kubernetes, or is it just
yeah, so sorry. Yeah, I was referring to we have a service interface in Golang that plugins can implement.
I see. Cool.
Yeah. And the plugins themselves are implemented with a package that is from Go. It's Go plugin. It's the gRPC Go plugin module from HashiCorp, and essentially what a plugin is just a long running process that Octant starts when it starts up. It starts it up. It finds out what port it is listening on, and then it registers that plugin API endpoint with Octant, and then it does the communication for all of the plugins across their individual API endpoints.
Cool.
So now we get on to more of kind of how does Octant display information? Mm-hmm. And there's three kind of paths that your request takes as it's going through Octant. And I am going to pull up a code editor here. I'm going to talk about it and then I'll kind of show it. So the first part is we have paths. And actually, let me just share this, and then I'll talk and share at the same time. Man, where is my little? I hate Zoom.
Yeah.
Okay. Where did the UI go? Why is it gone?
I don't see it.
Where? Okay. Stop? No.
Are you sharing just the window or the display?
I'm sharing my browser right now. I'm trying to stop doing that. Oh, there we go. Meeting controls. There we go. There. Okay.
Nice.
Now I can share something. Now I can share this. Okay. Now you should see that.
That looks familiar.
Great. Okay. So yeah, so kind of what happens when you make a request to Octant is the first thing we do is we look at the path, and so this is where it'll get interesting, because I don't actually. I'll just search for it because I don't actually know all of the spots where these things happen. It's path module path. No, come on. Fake paths. No, that's the build stuff. That's overview generator. Path matcher. There's one. All right. Yeah, so we have this path matcher. So what happens is the request comes in, and there is a path associated with that request, and we take that path and we break it down into its parts. And the parts contain a name. You generally speaking, they'll for like namespace scoped things, they'll contain a namespace and the name. They'll contain usually the resource type that we're trying to get at. So it could be pods or deployments, something like that. And then if there's more detail to it, like the actual resource ID, then it will contain kind of all of that information in the path. And so what we do is we break that information up, and we determine what the actual path, like the matching path is, and then we use that to go and get the object from Kubernetes. So it'll say like namespace default, pods, and then it will say like the container, the pod ID. And we'll use that information from the path to then start the process of describing the pod and then later printing the pod. The describers, which we have here, are generic enough that we have this idea where we either describe an object or we describe objects, and then we also have some things customized out for like CRDs. And so the way these work is that they take in. So after path matching has happened, we use that to create what will be the. There's the path filter. Let's see if I can find the exact spot here. Namespace. It's here somewhere. It's in this general area. It is. That's the load up. This might be it right here with the fields. No, we already have the object store there at this point. Let's see. Find usage. Yeah, here we go. Okay, so this is the generator. Yeah, the generator is essentially running on a loop. We have a loop that calls this, I believe, every second. And what it does is it takes the current content path, which is what I was mentioning before. It passes it through this path matcher here, and the result is this path filter. And then once I believe that's a path filter. Let me make sure. Yeah, path filter. So once we have the path filter out, what we do is we then use that to then query the Kubernetes API to get the object or objects that we're interested in. And the way we do that is we have this, as I mentioned previously, we use informers and a dynamic cache or dynamic client. Well, those are abstracted away behind this object store. The object store supports a standard set of CRUD operations: create, read, update, delete. And so you actually don't know if you're getting it from the informers or if you're having to do a real-time query, but you don't care. So
that's cool.
Yeah, so we grab that path filter and we load up all of this into these, the fields here, and these fields end up getting populated, as I was mentioning before, with things like the namespace, the link and the printers and all of these things that are going to be used for this object. Also the load object and load objects factory functions. Those are what these are, just encapsulations around fetching an object from the API. They take in the desired like namespace and fields, and then wrap the get and list methods. So that way, when you call them, it's just a single function call, and we've already used closures to kind of determine what the arguments are.
Cool.
And then so then we call this describe, which that's where we came from previously, and describe will take in the namespace and the set of options. Options again being determined from the path filter and the generated fields, and it will then produce a content response. Now the content response is essentially the JSON that you see when it gets marshaled. So we have a title, a set of components, extension component, icon name, and icon source. These are the top level fields for a content response. Components, as we mentioned before, are that the term is a generic reference to any visual object, be it a card, a table, a list, a text field. Any element that you see when you're looking at Octant is a component. So we then we marshal that to JSON, and we put it onto the stream. To marshal it to JSON, it's the object describers will go and gather up all of the different tabs and information that we have. And the result of that is then those tabs will start to call all of our printers. And our printers, our printers here, you can see these start to make sense, right? They start to have actual types associated with them, and you can see that here's the printer for pod lists, and there's printers for replica sets, deployments, jobs, all of these things. So and even custom resource. So the way that's the way these transformations kind of happen. It's a little magical and hand wavy when you're looking at it in the higher abstractions, because it's all interfaces and reflective types. But what's really happening is that we have defined a set of printers. A printer knows how to turn something into a component, and a component knows how to create JSON for the things that have been that it represents. And then content responses are made up of a list of those components. And so when we marshal it to JSON, we then put it on the stream, and it's all the objects as JSON. And the way this is done, I'll show you this is like the let me find it. Here it is, I think. This ready? Yeah. Okay, so this is this is in view component in base.go. This is kind of our this is why it's all hand wavy and hard to follow sometimes. So we have a set of types that we define. These are all concrete component types that can be this is essentially a list of anything that can be marshaled or unmarshaled from JSON, or marshaled to JSON as well. And what it does is there's this list of concrete types, and then we have another. It is, let's see, what is it? It's like here. Yep. Here's a good example, because we just did this one. So we have that list of concrete types, and then we create this marshal JSON function, which we assign it this metadata type, and then we call marshal. And what that does is there is a metadata object or metadata printer, and the metadata printer takes that type and assigns it, and then also knows how to ensure that the type of it gets passed on to the rest of its the output in the stream. Sorry, the actual JSON that's getting outputted. And to do that, it uses this object and link interface, which I still to this day do not fully understand exactly how it all works. Like, I know that it does work and I can make changes to it, but like there's still an element to this where I get confused by it, because I'm like, I guess it works. Because it's just like this long, it's essentially a long chain of calling Marshall on all of these objects. And some of them are interfaces and some of them are concrete types. And you go and you fill out exactly how they need to be marshaled or unmarshaled. And then this, as long as everything in the chain has marshal and unmarshal commands, it does the right thing.
Cool. Yeah, so it's like a black box for me now.
Yeah. Yeah. It's not completely, like, you can get into it and understand it, but I still will find myself getting confused by it. And I'm very familiar with it, and I make changes to it, and I still find myself getting confused by it occasionally. So the main thing here that I want that I think it's important for you to know is that the path filter creates the set of options that gets passed into the describer, so that the generator is being called. The generator has the content path that is currently being viewed. That creates a set of path filter options that then get passed into a describer, and the describer is responsible for generating all of the tabs. Let's see if I can, right there.
Cool.
So the describer is responsible for generating all of the tabs that you see in the main Octant views. So the summary tab, resource tab, everything like that. Cool. Those describer tabs are made up of the printer output of the components that have been matched by the path filter.
Okay. No, it kind of makes sense. I really like how it seems to be really extensible.
It is, yes.
So you can easily add the different types, and what may help, and I may try to do that on my own, is because I like to think visually, so I may try to make like boxes, how things are connected. It may help me, and if it turns out it's something, I may add it to the Git.
Yeah, and like something you could do just in that same vein of like trying things out is you could come in here. I mean, I'm going to do this quick, and obviously I know that I have a lot of context here, but in object.go in the describer, right, you could come in and you could say, I'm gonna add this, and right, and then I'm gonna go and add myself a function that will generate or describe this tab.
Cool.
And then in there you could do all sorts of creating your own components and printing them and getting them just like have the describer output that as a content response for the tab, and you could then see that kind of being rendered out in real time. And that would give you a good understanding of how to work on the back end and have it be viewed in the front end. Another way would be to just write a plugin. Plugins give you kind of that same freedom, but you're kind of scoped to the external interface that we've just prescribed to plugins. But it's still, there's a lot of the same ideas happening with plugins, which I was going to talk about here.
Cool.
So any other, I mean, like I said, I'm covering this stuff fast just to give you like some detail. I don't know, like we can always come back and deep dive into some code later, like as you explore it more. So
this is perfect. Yeah. Thank you.
So
makes a lot of sense.
The next thing I want to talk about was how Octant does edits and updates.
Cool.
So you're looking at some resource and you want to perform a delete or you want to update it or something like that. And the way we do that is with actions. Actions are, let's see, project. There we go. Oh, where's it at? I always have to, I can never find the thing I want.
Yeah, it's hard. It's a big project.
It's also just like there are, yeah, this will work. This will take me to where I want. Package action manager. See, that's not even what I want, but okay, it's fine. This is fine. So actions are essentially just a map that is a string, and there's a function associated with that string. And so what that looks like on the Octant side of things is actually here. Let me I'm going to take this moment to start Octant here. And get it pulled up. No. Oh, come on. What is this? Wrong cube. Yeah. Well, yeah. So I'm just getting my proper cube config in place. And then I'll share. Okay, let me share this screen over here. And we will. There we go. Okay, so you should be seeing a view of Octant right now.
Cool.
And do you see the developer tools or no? Of course not. Now you see them.
There you go.
Okay. So let me just show this. Do I have some plugins, but not the one I was hoping for. Anyway, I think there's a pod here somewhere. Yeah, here we go. Okay, so no, there's no port forward on that. Let's do this one. Nothing there. There we go. Sure, why not? Okay. So we have the stream down here, which I will pull up, which I think is it this one?
Yes, I've seen that. Cool.
Yeah. Okay. So when I click this start port forward, what happens is there's this action that gets sent, and the way this looks is I can show it to you here. It's really simple. Wait. So you can see it is there's just a in this case the payload is just the content path, right? And the action itself was sent to, there it is right there. So we got this content path. Yeah, so we have this perform. Yeah, I'm on the right one. So we have this perform action is the type, but really what happens is there's this payload and it sets the action, and it's just overview, start, port forward. And then it's got a set of, just options that you can pass in. So in this case, it's the pod, it's all the name, the port that we want to forward to, etc. So on the back end, all of this is to say that on the back end, what's happening is that there is a action with a name, and the action name is this right here: overview / start port forward.
Cool.
And then inside the action handler code, which I can show, is the inside this action handler code, you have to manually go and you have to manually go and check everything that you are looking for, because we just map it to I'm not sharing. Hold on. So here's the port forward action. So there's this action name.
Cool.
And then we have this handler, and in the handler is where we go through and yeah. So in this case, we pull all of this information out of the payload, and you can see here we type check everything. So we try to get the string, we try to get the string kind, the string name, namespace, port. Port's coming as a unsigned integer, and then once we have all of that, we create this port forward request, and then we call our validate method, which ensures that does more checking and more work. But the main thing that was happening here is that we just map a handle function to a string.
Cool.
And then we register that with Octant. And so plugins, they get to do the same thing. For a plugin, it essentially looks like plugin name / the action name, right? And it registers that action with Octant, and then plugins can also have custom actions. So
nice
things that get triggered in that way. So that's really all there is to actions. They're not they're very useful and very simple, which is great.
So how does that get propagated to Kubernetes?
So the action handler itself is what does. So once Octant has called this handler, it's up to the action to then implement what it wants to do. So in this case, that handle method is really a wrapper around this create forwarder method, and this create forwarder method uses the Kubernetes API to make a port forward request. It does so right here with a REST client, and it just posts to the Kubernetes API.
Nice.
And that would be same with any action. Like the Octant, all Octant's doing around actions is saying, you've received a request and here's the payload. And then what you do with that payload as the action is really up to, you can call Kubernetes, you could call some third-party service, you could do whatever is necessary with the action.
Nice.
And then it's your job just to respond back with like, okay, I'm handling this, or no, that was a bad request.
Cool.
And it's usually assumed. So the way Octant calls an action is it just calls it, and it usually it's assumed that you're going to return either yes, this was a good request, or no, it was a bad request. Okay. And then if there's like long standing work to perform or something like that, you would generally run a go routine, queue that information out, and then use an alert or whatever field you're updating in the UI would then later have any type of status update or error message or things like that.
And you'll get notified at the end when it's done, right?
Right.
Cool. I love it. This is pretty cool.
So let's see. I wanted to, and then plugins. So since we're talking about actions and plugins, we have an example plugin that I can go over real quick. So there's a few plugins on GitHub that folks have written, as well as some that we've created just as examples for testing things out. This is our sample plugin that lives in the repo with Octant.
I've seen that.
Yeah. Okay. So it has the ability to handle a custom print, handle a custom tab, and as well as it shows how to do custom navigation. So
nice.
We already talked about how they register themselves with Octant, and then Octant essentially calls the methods that are there using the service interface. And so the thing I think that's most important about plugins is that they are essentially no different than any of the other types that are in Octant. They have a limited surface area in which they're allowed to interact with the Kubernetes API and where they're allowed to print things, but how they print things, how they render components, how requests are handled internally, how they perform actions is all identical to things that are internal to Octant. So so by kind of knowing how plugins work and using plugins, you get a good idea of how Octant behaves and works too. You can really get a sense. I think the feedback loop on plugins is faster because you can write something to do a print, create a new tab, and you just recompile your plugin and restart Octant, and it's, you can instantly kind of see that your component is rendering how you would expect, or your card is doing what you would expect. It's a good way to get a feel for the streams. And it also is nice because when you're looking at a plugin stream, do I still have Octant up somewhere? What do I do with it? Yeah, I do. One of the benefits of using plugins as a way to kind of get a feel for Octant is that when you go to like the sample plugin here, when you pull up and look at the stream is much it's much smaller. There's not a whole bunch of extra information in it. Yeah, so you can see it's just the stream for the plugin.
Cool.
And so it lets you kind of explore and look at streams without having all of it at once in this, like all of this metadata and all this information that Octant's using, that if you're just exploring things, you don't really care about.
So that means that plugins are self-contained and they operate on their own set of data. Is it possible for them to interact with other parts of the stream?
Yeah. So what they do is they specifically. Let me actually reshare. Let me reshare the code window there. So plugins can register what they support, and so what this means is that you take like a GVK for a pod, and you say that my plugin can support either, like in this case, printer config or supports tab. What that means is that if somebody goes and I think it would happen on the one I was just showing you, but what it means is that if someone goes to the plugin or someone goes to the pod, you will see an extra tab from your plugin. And what it does is you actually get that object in your plugin on the request.
Okay.
And then you can go and do extra things with that object, or you can, if you have some third-party API that you're using to map data from this object type, and you want to go look it up, you can take this object and go do and fetch that information, and then you can display it right in the same view that Octant is using to display the information. So you can see here, I have this extra pod details.
Nice.
That comes from a plugin.
That's awesome.
And then on the summary page, this right here, the status, that extent, that this comes, these fields here, they come from a plugin.
Very cool.
And you can see if we just watch the screen, it's just updating that timestamp. That's all this plugin does. But so this could be doing a multitude of things that are related to either the object or whatever it is you're trying to view. This was the resource viewer that I had mentioned before.
Right.
So
cool. So I assume that's another component, right? That gets its registered, that specifies somehow this is kind of data I need, and then it receives it, and just the printer does things a little differently.
Yep, correct.
Okay, cool.
Yeah, and we can even look at so you go resource viewer stream and just you'll see that it I believe it's in the second, which tab is it? Summary, metadata, there it is, resource viewer. Yeah, number 2. So you can see this this third element of the view components array.
Okay.
It has this it has the value resource viewer here, and yeah, it's just all you can
data it cares about.
Yep, edges, nodes, all of that information gets spit out here, and then there's a view component on the Angular side that knows how to take that data stream and turn it into this useful display.
Nice.
Yep.
That's awesome. I really like it. It's really great architecture, I think.
Yeah, it works out to be very flexible. It also is very nice for controlling the way things render and the way things look on the screen. So we're not having to constantly be in there nudging CSS values and
right.
working with some grid layout thing and CSS and all that. Like we have defined it in components, and the components get written to a stream, and then the front end renders them. And so the most common thing on the front end that we're dealing with is the initial setup of the CSS, so that when it does render the component, it looks like we want it and does the things we want to do. And then how those components in that CSS interact with the other components on the page.
I see.
So that, but the actual pieces themselves, like all these cards, this table, these all just get put onto the stream from the back end, and the front end does what it's supposed to do. So yeah, and that was really, I think, I'm gonna look at my notes real quick. I think that was the main things I wanted to go over quickly with you. And then I was going to have just say any questions, and then also if there's specific areas that you want more detail on, I can sit down, take some time, come up with some more detail, or like a specific code walkthrough of areas, and then we can do this again.
So maybe just one thing, we didn't do much front side. So maybe just if you can show me how the components, UI components, are mapped to this, and based on so what I assume you have for each one of those cards and views, you have component, and how does that, is it routed through internal router, or what defines your layout in the screen?
Yeah. I can definitely show you how we do that. It's so we basically have there's like the main root of the app, which if you said you're already familiar with Angular, so we have
right. Yeah.
we have like the main app routing here, and the main, and it's a very simple. It's very simple. There's nothing complex here.
Right.
And then right now Denali is the Electron app, and then Sugarloaf is what we call the current web version of Octant. So the components themselves, in the same way that you saw there was printers and components for each of the types, we also have that on the UI side. And the way it actually gets mapped in is, no, where's it at? We have a giant
switcher, yeah.
Switch, yes. Yeah, that's exactly what we have. Where is it though? Why can't I ever seem to find this thing?
Content.ts.
Oh no, that, you know why? Because I keep using the hold on. I just switched to Goland and I don't fully have the file content.ts. Thank you, Sam. So yeah, so this content.ts is the actual interface definitions for all of the content types. And so what, and then we actually have a switcher. Nope, that's not it. I keep opening that one and I don't, you know what? Here we have this which I don't know about this. It works. I think there's probably there must be a way to not do this, but we do it and it works, and it's and so that's the purpose it serves. So right now when we're reading data off of that stream, we look at that metadata type, and then we go through and we switch on it and load up each of the types.
I see. Interesting. Cool.
So if you want to change that,
container,
you can change that. There might be a better way. I don't know. I'm not an expert at all. So
I mean, you guys have a lot of views, so this is one way to keep track of them. Maybe using a routing. I forgot how routing works in Angular. Maybe this is the way to do it. I don't remember, honestly.
Yeah. I know that there is potentially some conflict with the Angular router and how we do. We rely heavily on the path with that path matcher and path filter to determine what we should load on the back end. And I'm pretty sure that if I'm pretty sure there's some complication or some conflict between what the Angular router thinks the browser URL should be and what we need the browser URL to be to properly load components.
Cool.
So that is why that is the reason this big switch statement exists. But that doesn't mean there isn't another way, or that, and it also doesn't mean that this is the worst way or that this isn't the right way. It just means that whenever I see this, I think there must be a better way, but I don't know for sure. So
cool.
Yeah, and so that's how those work. And we have I was going to show one more thing. It is, where's it at? I guess I could just show an actual component here, like a present. Card's a good one.
Cool.
So this is the cards. So this is like an example of what our components look like.
Nice. Pretty much standard component.
Yes.
Angular component. Nice.
Yeah. This doesn't. There's not a whole lot of unexpected behavior here. It uses this card view as its interface, so that way the reason this is here is so that it's easy to unmarshal to this data. So we read the data off the stream. The switcher goes through and looks at that metadata field for the type. It encounters this type card view, and then it's able to unmarshal that card view to these values on the JavaScript side, and then we can use it like the card view object in the component. And yeah, cool. And then most of our components use this on change, and
update the state. And UI, cool. And then you have actions. Nice. Sweet. That looks really nice.
So I think one of the things that I would be interested in knowing as well is if we can somehow not do the, I guess I think that we probably update the views. I think there are probably some cases where we're updating our views and when we don't need to be. And I would be interested in knowing if there's some way to make that more efficient, or to not, because the way we do it, because we're streaming this out and we basically just are on a loop every second, we're sending out new stream information. Right. I think there's probably some back-end changes that can be fixed so that we're only sending information that has changed. But in the meantime, or maybe not in the meantime, maybe that's just what we need to do so that we're not spamming it all the time. Like, it just seems like, you know what? We need to fix this on the back end. Never mind. That's how I feel about it. Because we currently send the entire stream of data every second.
I see.
Even if, and we let the front end determine if there's been changes.
I see. So how much data we are talking about for deployment?
It's not. I mean, it's if you open up the dev tools and you open that stream, you can see that it's each of the every second it's the full content of the stream.
Okay.
Which is, I don't know what the requirement. Let's see, it is 30,000 bytes for like the pod view.
Okay.
It's not no, it's not that much. It's just there's a lot of JSON and a lot of objects and a lot, like, I'm pretty sure that we have to, I don't know if this is true, but I think that we probably, every time we receive that stream, we probably go through this whole switch statement.
Right.
And then as it's going through each switch statement, it goes, there's no update here. So that's something where on the back end, if we can just only send it when there's updates, I think we'll probably see a lot of speed improvement. But that's, yeah. But that's that's a different thing. That's outside of the scope of what we're talking about now. So,
cool.
Okay.
No, that's definitely something to keep an eye on in the future.
Any other questions, things you'd like to see?
No, this was really informative. Thank you so much. I appreciate it.
Okay. Sam,
I have a good picture.
Anything you want to add, Sam? Anything that?
Yeah, there's one part that I think would be helpful to look at as well. It's under package view components test data. And there's just a lot of JSON files that are just the representations of what things look like. So you don't have to keep digging through the entire WebSocket stream, and you can actually just see what the components and properties are, and just even see in the context of tests how they're used. And it's a good way to just understand what the properties of a component might be.
Cool. Yeah, so that's a good point. What kind of tests you have on the project? What level of testing you have on end-to-end? Yes. I've seen some end-to-end tests, and I've seen a lot of other tests. So.
Yeah, so on the Go side, we mostly use, like on the Go side, it's pretty much all unit tests. And then nice. on the front-end side, we have a lot of our unit tests on the front-end side are bare bones, like make sure this thing compiles and doesn't have any type errors.
Okay.
They don't do a lot of exercising of the unique properties of any of the components. We have some that do, but I would say generally speaking, most of our front end tests are very much the minimal requirement to say you have a test for that component. We did some work around having some integration tests with Cypress,
Oh,
and
nice.
we need to revisit it. Currently they're turned off because we were getting a lot of intermittent failures and a lot of like jitter type bugs where it would pass one time and then not pass the next time, and so we wanted to we were recently moving to GitHub Actions, and so we wanted to we turned that off. We're moving everything over to Actions, and then we're going to start to revisit how we want to handle some of our integration testing and full end-to-end tests. So if you have experience in that from the front end side, that'd be great.
Yeah, we just started using Cypress last few months on our data visualization project, and I liked it a lot. It's definitely great tool, a huge improvement to all other integration front-end tools I've seen. So I definitely can help with that.
Yeah, I know Sam was doing quite a bit of work around that, and so I think collectively we can probably all come together and figure out a good solution for end-to-end stuff. And
cool.
I think another part of this as well that Sam and I discovered as we were going through it was some of this stuff is hard to test because it's not written in a way that is probably the best for front end stuff. So like there are some of the ways that we do interactions and trigger events and things like that, where if we refactor those, then we can probably remove some of the intermittent weirdness in our end-to-end testing.
I see. Cool. Awesome. Yeah, that makes a lot of sense.
Well, I don't really have anything else. I made a note about the test data stuff because I think that's a really good thing to call out, Sam. Thank you. And yeah, that's all I got.
Yeah, one other question I have, which is not related to this, is how you guys decide priorities and what to work on, basically. So for me, directly, what should I work on first? How do you do that typically?
Right now, typically, Sam and I talk to each other and we say, hey, this is what we're going to work on. So we have a weekly community meeting.
Right.
And that weekly community meeting, if anyone from the community brings up issues that are blocking them related to like plugin development or things that they're trying to get done, we usually tend to prioritize those first. And then we go through kind of our outstanding issues in ZenHub and try to find things that kind of align with like the work we're doing, and prioritize that just by moving it into the sprint backlog lane in ZenHub.
I see.
As for and then like the overall direction of the project and like what the roadmap and like long-term goals are, that comes from Brian. And so we use the information that Brian gives us to kind of inform and direct the prioritization of issues, and then we combine that with the community feedback. So as for like it's like there's usually a theme of like, okay, this round we're going to focus on plugins, or this round we're really focusing on bugs, or this round we're adding new features. And that theme is generally communicated at the community meetings and throughout the current, release cycle. I air quote release cycle because we were doing like a 2-week release cadence, but that really wasn't as important as it was to kind of make sure that we were releasing either new high quality features or bug fixes more than the cadence itself. Like people really didn't care so much about us releasing every 2 weeks as they did about getting either a new feature or the bug fix they wanted. And so we've introduced nightly builds, which people take advantage of now. So when we land new fixes, people can go download the latest nightly and start to use those right away. The convenience of Octant being a standalone executable where you just double click it and it goes is that they just download those and overwrite their existing file. As we move forward with making Octant an application, it'll actually, the external release schedules will even get a little more fuzzy because we'll be doing in-app updates. So you won't like they'll launch their client and it will get an update and fetch it, and then it'll refresh and they'll be updated. So the idea of a like structured release around Octant is going to be focused more on the API. So the specifically the plugin API. So like this next release that we're doing has breaking changes to the plugin API. So we're going to be sure to bump the version, a full number, in this case, it'll be O dot, what are we, O dot 11, O dot 12, O dot.
Okay.
Sam, help.
11.
Oh, okay. Yeah. I'm like, oh, I forgot. Yeah. So it'll be O dot 11. And we'll make sure that we highlight the fact that there's breaking API changes to the plugin system. As we move towards 1.0, our goal will be to not have breaking changes to the API. And only for very, very good reason would we. And we will also, there'll be API changes will be, -1 +1 on the support. So we will essentially we'll have V1 if we have a V2, and then we'll have eventually like a V3 and V4, and then we'll deprecate exactly. So if you're familiar with that kind of style,
that makes sense.
So the actual Octant version will kind of become fuzzy. The plugin API version will become the more important thing, and then so we do try to release, like we will probably do a release here pretty soon, just because we have enough committed and enough updates and fixes for folks that it's probably worth doing one early next week. And but yeah, that's kind of not they're not like a priority with respect to it must go out. It's a priority with respect to what's the quality of it.
And community requests too.
Yeah, and like what's in it, right? Yeah, exactly. Cool. So as for you with priority, I would say that you can kind of like look at what's in the sprint. Like just if you look at the Zen Hub now and look at what's in the sprint backlog, and kind of pick any of those. And if there's not a lot to pick from right now, we can definitely, Sam or myself can definitely get you set up on the right thing. I can just go. I think there's enough in there though that
I see a couple of enhancements and free CI/CD things. Am I looking at the right thing? That's the
let's
6
see.
issues.
Yep.
Cool. Yeah, I'll take a look.
So yeah, so there's some, and then also the back. I would say we have done a good. So our sprint backlog is all immediate things that we know we want to work on now. The backlog is usually things we know we're going to work on soon. And then the icebox is who knows. Right. Things go from the icebox to the sprint backlog based on community priority as well. Like we've definitely had issues that were in the icebox that jumped right to the sprint backlog because we're at a community meeting and someone said, this is really important to me. It's really just like my day. I start my day, I log in, I go to Zen Hub, I look at what's there, and I just try to work through issues. And then when those issues start to get low, or we start to get into a point like we are now where we're probably pretty close to cutting a release, then we work towards cutting that release and then go through and triage and make a new fresh list.
And I assume things in backlog are sorted by the priority, or is it no? Just
no, it's pretty random in there. We try to, so Zen Hub makes it very hard to keep stuff sorted by priority in that column. Cause like when you drag it, like, especially if you're like mid scroll on one column and mid scroll in another column and you want to move it, the options are kind of the middle, above some random issue, below some random issue, or wait a whole 10 minutes while you scroll down the whole list to get it. So it may be something as we wait, like when we get the rest of the folks on the team, we might want to look into like having a because I assume the amount of bandwidth we're going to have to be working through issues was going to go faster eventually, and we may want to have like a we may just want to use Icebox as the backlog, and then make backlog kind of the prioritized list, and then sprint backlog would be the immediate, and then do something where we're like, we only ever like no more than 20 issues in the prioritized backlog list, because there's kind of no point in going past that. There's just,
right.
Like you prioritize more than a handful of issues, and eventually the priorities don't mean anything. So that's something we can look at doing, just kind of make it easier for people to pick stuff off the stack when we
have a bigger team. Yeah, makes sense.
Yeah, exactly.
So one thing that all makes sense. Thank you so much. One thing I'm still in the dark is maybe be done. If you guys don't have time, you don't have to do it now. Is the CI/CD, how you do that, and release where are the releases and things like that. I assume it's on NPM, right?
No, so it's
okay.
So we do the release on there's Brew, Chocolatey. We have the releases on GitHub, and
cool.
I think there might be one more, but I can't think of it right now.
So how about CI?
Sam recently just did a bunch of work of converting our CI/CD checks over to actions. So right now, all of that happens through GitHub Actions. Nice. We do our linting, we verify generated code, and then we have some pre-flight checks that happen across the platforms where we do Mac, Linux, and Windows. And then once those are confirmed, then we have this integration build that happens that ensures that all of the assets themselves can compile together and
cool.
Yeah. So, or did we renamed it? I don't know what it's called now, but essentially there's a bunch of linting that happens. Like the linting happens at the same time that the cross-platform pre-flight checks are happening, and then the same with the verified generated code. So all of that gets run. I think there's I don't know, 12 checks in total or something, 14 checks in total.
Cool.
And they take the slowest ones take about 7 minutes to run. But they run in parallel. So like the total time for all the checks is about 7 minutes.
They run on all branches, I can see. Right.
They run on any pull request, and then as well as any upstream branch.
Okay.
And then they also run when we do tags for the release.
Cool. So it looks like you do almost everything as the PRs, right?
Yes. Yep.
Okay.
Yep. The standard way to kind of work is to fork Octant and then do it as a PR from your fork.
Okay.
Occasionally we'll create an upstream branch if there's something that's like highly collaborative where both people are going to be pushing commits into the same branch at kind of a rapid pace. Then we'll create an upstream branch to facilitate that process. But generally speaking, we work out of our own branches.
Cool. Awesome.
And I'll make sure that you get added to the project because I don't know.
I think I already am.
Okay, good.
Yeah.
Good.
So I can see settings, so I must be.
Yep.
Must be there. Awesome.
Okay, cool.
Yeah, thank you so much. I appreciate you taking time and walking me through all this. This was so informative. So I'm assuming I'll just start poking around the code a little more and then start grabbing the things from the backlog?
Yeah. So if you're ready, like if you're ready for an issue, then